Hello, everybody. I'm Mike Isbitski, Technical Evangelist with Salt Security. We're going to get started with the presentation. Thanks for joining today. We're going to be talking about the need for automation in API security. I'm also joined by a colleague of mine, Nicolas. Nicolas, I don't know if you want to quickly introduce yourself. Nicolas is actually going to be doing our technical demonstration later in the session.
Absolutely. So I'm a API security engineer for France at Sol Security for almost 3 months now. And yeah, I'll be happy to present you the product during a brief demo today.
Thanks, Nicolas. All right, this is kind of the theme for the conference, right? If you're working with APIs, this probably isn't a new concept. Software is eating the world. It's kind of a famous quote by Mark Andreessen. Really, it's APIs, right? APIs are the way that we build applications and systems. They underpin everything. So not terribly shocking quote, but it is kind of the evolution of things, right? It's the world we live in. Unfortunately, you know, by virtue of that, attackers also target APIs. There's no shortage of API incidents. There's many American companies that you see here with very massive data leaks or scraping incidents that expose a lot of customer data. In some cases, these are privacy impacts, such as with Peloton or Experian. But the end result is data is lost, customer data is compromised. There's also many French companies that have suffered similar incidents. There was Ledger, the cryptocurrency hardware wallet manufacturer that had an API issue. I believe that was in 2020. Then more recently, Doctolib leaked patient healthcare data. So it kind of crosses all industries when you start digging in, even just a little bit. The frequency of these incidents is actually occurring quite often now, right? It's not like it used to be where you'd have one every few months or maybe once a year. It's almost weekly or daily at this point. And along those lines, Gartner, a global industry analyst firm, predicted that by 2022, API abuses would move from the most infrequent to the most frequent attack vector. And we're here, right? You kind of see that with the evidence of API incidents, like I was describing. So Gartner's going to have to update this prediction pretty soon, but it's here, right? We're almost in 2022, so this is the world we're living in. These are the topics we're going to zone in today. I did tell you that Nicolas is going to be doing a technical demonstration a little bit later. I think that's kind of the meat of this presentation, right? Kind of looking into what are the things that you really need to find your APIs and protect them, right? Because traditional approaches just aren't working, unfortunately. So how do we get here? Why are these incidents occurring? uh, the attack surface has really changed, right? If you think about legacy of application development or systems engineering, APIs used to be much lower in number, right? You kind of had monolithic design. Things really changed, right? Many organizations were uh, utilizing waterfall methodologies as opposed to agile methodologies. So the rate of change was much less frequent. And sensitive data just wasn't exposed, right? Those APIs were typically restricted, right? Partners, was very controlled set of partners and suppliers that could get to that data. It was very rare that you might even expose an API publicly. Today, it's much different, right? We have thousands of APIs by virtue of things like microservices architecture, and they frequently change, right? By virtue of agile methodologies and also DevOps practices that allow us to release things much more quickly. And there's a lot more sensitive data that is being exposed, right? Because we are creating public or open APIs. Things need to be internet facing so we can provide functionality and data to customers or employees or citizens, right? It really depends on the use case for your organization. The attacks are also changing, right? What they used to be, it was kind of known injection attacks most often, right? SQL injection, cross-site scripting, specifically in the world of APIs, and might have been things like XML injection. These days, maybe more JSON injection. Really depends on the APIs you're building. But attackers were finding exploitable APIs that way, right? What is the payload I can craft that I can inject some type of code and do something in the back end? And that was often one API call, right? So they would just probe continuously, try to find the right injection that would bypass your API gateway filters or web app firewall filters. So it's fairly easy to detect, right? Not every organization was even doing that well. But the reality today is many of the API attacks are actually business logic attacks. So they are targeting the business logic that you are building into APIs, right? So like a scraping attack with an API, you may have built that to expose data purposefully, and an attacker is actually just enumerating through your entire customer data set and scraping things slowly, right? So the API is doing exactly what it was designed to do, just somebody's using it in a malicious way. And the attacks are low and slow, right? It's a sequence of API calls. They probe things slowly. It's a kind of intermittent sequence, right? I'm not necessarily going to hit things sequentially as an attacker because that's not necessarily how you've built your application or system. It could be 10 or 20 APIs I hit in different sequences. And some of those might be third party as well, right? It might not going to be everything that you own. So attackers will spend days or weeks doing this passive reconnaissance to kind of understand what is the business logic of what you designed and how can I kind of abuse that. So not so much those code injection attacks. There's really some questions you need to consider when you're thinking about the security of your APIs. And many organizations are not great at this, right? It's kind of the state of the industry. We're all relatively low maturity when it comes to protecting APIs because relied on traditional approaches like access control or those message filters I was describing. But these are often a problem, right? Do I know all the APIs in my environment? It's really an API inventory question or API catalog. Many organizations would start with their API management platform and pull from there. But those are only the things that you've formally published and are mediating. The APIs that you use and consume are much more than just that. And then where are your sensitive data exposure points or private data exposure points, right? Because we are held to the standard of things like GDPR, right? Depending where you're doing business or what citizenship you're kind of dealing with, you're bound by different regulations. So really important questions that you have to be able to answer. Unfortunately, web app firewalls and API gateways just can't help, right? They don't really provide a form of API discovery. At best, you're getting logs that maybe you can analyze after the fact, but they don't have capabilities that help you construct the API inventory that is needed to drive API security strategy. They can only prevent known attacks, and typically those are injection flaws, like I was describing on the last slide. And the way they're built, because they are essentially proxies, is they're analyzing API calls or API traffic one request at a time, right? Or one frame, right? If you kind of think of it in the concept of a movie. What's really needed for API protection is, you have to have this automated discovery of all of your APIs, not just the things that you know and are formally publishing. There's likely other apps that are being built that may not follow formal build process and flow through your CI/CD build pipelines. There's also third-party APIs and APIs you acquire, right, from commercial packages or software as a service providers. How are you inventorying all of this? And then any tooling has to be able to understand the unique business logic of each of those APIs, right? What does the REST API look like? What parameters does it accept? Are those in the URL? Are they in post payloads? What's the right sequence that you exercise things in? That's kind of the business logic, right? And they need to provide this broader view. You need context across all users and sessions over time, or that whole movie, right? We can't look at one API call at a time and recognize that as an attack or abuse because that's just not how they manifest themselves. And just to add back to those questions, if your CISO asked you tomorrow, would we know if somebody was attacking our APIs right now? That's a really hard question to answer for many organizations. I've been there myself, right? It's really hard to know everything that's going on and with your entire attack surface at any given moment. And then specifically with API security, can you stop the OWASP API security top 10 threats, which was last updated in 2019. It's going to be due for a refresh soon. Many solutions just fall flat there. They can't protect you from everything. One other thing worth mentioning is API specifications, right? As we are API builders or developers, we're hopefully documenting things, right? And typically that is an API specification like Swagger or Open API spec. Maybe you're working with other formats like API Blueprint or RAML, right? There's no shortage of formats, right? And older web services had their own as well, right? If you're working with SOAP. But these API specifications are important, right? They kind of drive full lifecycle activities. They're useful for testing. They're also useful for protection, right? If you know exactly how an API call should look, you can kind of enforce that or restrict API calls to only the traffic should only look like that, right? And drop it at your proxies. The problem that occurs is that documentation is a manual process, right? And we're all human. Documenting is kind of a grueling process, right? It's something that often goes by the wayside. So at best, usually you see things at launch or maybe version 1 of an API is documented pretty fully, but then things start to drift. So the reality is typically that this is actually a screenshot of the Salt platform, but the reality is that your traffic is going to look much different than what you've documented. The other pitfall with API specifications is that there's only so much that you can define in the specification that actually protects you from certain types of business logic abuses or attacks. And in some cases, you don't even need to fully define all of the URL parameters, post payload values. They can be pretty flexible, right? So if you just say it's a string, well, what should that string look like, right? And attackers will manipulate these things. So schema enforcement, though beneficial to an extent, it's very hard to kind of define everything fully up front, but then you're still going to be missing attacks. How Salt complements API gateways, and really this is kind of how you should consider any API security tooling. Yes, I work with Salt Security, so we'll be talking about Salt today, but any solution you look at should be able to do these things, right? And complement your API gateways and API management, right? Those I hesitate to say it's just a mechanism, right? Because it's kind of a suite of tools that help you build and publish your APIs. But the mechanism that's useful for security is typically the API gateway component, right? It's what's mediating your API calls. The capabilities that they provide for security, they are relatively limited, right? We talked about message filters that can potentially block some injection attacks, although they tend to be very basic, right? Looking for known malicious character and then blocking that. In some cases, that can actually break system integrations. So it's not uncommon that organizations would just leave threat protection filters turned off. They are useful for traffic management, right? So rate limiting or use limiting, quota management, those types of things that can kind of restrict an API abuser that is trying to enumerate and scrape your APIs. The problem is it's hard to scale those things, right, without the aid of machine assistance, which is kind of where Salt comes in, right? Well, what is the context? What is this caller potentially abusive? And then do I want to kind of throttle them down and institute essentially a dynamic rate limit on that API caller? And API gateways are definitely used for access control enforcement, right? They're kind of the pairing with identity and access management systems. So when an API caller attempts to access your API, you certainly want to be authenticating and authorizing that user or machine identity. But again, the problem becomes scale, right? And then all of the API calls throughout the layers are you validating authorization levels consistently? That gets incredibly challenging. And we see that actually more commonly now with GraphQL. So how has Salt architected the platform? Again, this is what you should really be considering in any solution. And Nicolas is actually going to cover some of this live when he gets to the demonstration. But you do need integration points at various points of your enterprise architecture, right? So if you are in Kubernetes, do you have Kubernetes ingress connection? Can it integrate as a sidecar? If you are operating load balancers or delivery controllers, and most organizations are, such as F5 or Nginx, can you integrate with that to gather all of the telemetry? We've talked quite a bit about API gateways, so that is certainly a logical integration point. But you need to be able to gather telemetry from all of these points of your architecture, because that's how APIs function, right? They are very disconnected or disjointed, and ultimately they work together to enable functionality and data exchange. You also need to be able to analyze all that telemetry, right? It's not enough to just be able to collect all these signals. You actually have to analyze it. And that's where machine learning and AI come in. To kind of produce useful signals to your teams, but also tell you, like, is this actually an anomalous event or a potential attack? At Salt, we call that our API context engine, or ACE architecture. It is patented. You can look it up if you'd like. And ultimately, all of those signals feed into our API protection platform. The primary use cases, there's kind of three, if you need to boil it down, although organizations are all unique, right, in how they're building APIs. But ultimately, there's three kind of high-level categories. The first is API discovery and sensitive data discovery, right? We kind of talked about that in the questions. We need to be able to detect and stop attacks, which includes not just exploits like code injection attacks, but also abuses like enumerating, scraping, credential stuffing, those types of things. And finally, we want to kind of create feedback loops, for lack of a better word, but improve API security posture over time. When you detect an attack, maybe it's a misconfiguration in an architectural component, like an API gateway or load balancer. Typically be something like a rate limit, but it could also be something in the code of that API, or maybe it's an access control policy that you have to configure in identity and access management, right? So it's not as easy as fix the code or deploy a patch. That's not the world we live in with APIs. So provide the right intelligence that helps IT teams kind of diagnose where is the best fix to mitigate this API attack. This kind of dives in a little bit deeper, and I do want to make sure I save time for Nicolas' great tech demo. But really, that inventory is critical, like we're describing, not just for protection, but also compliance needs, right? And your risk teams are likely looking for these. I mentioned GDPR, but there are many others, right? Regulations are kind of what bind all organizations. You have to be careful with your data, how you transmit it, how you process it. That's just the reality. We talked about OWASP API security top 10 threats. There's only 10, right? There's many more that evolve out of that. That's kind of a starting point to think about. You should absolutely be able to address them, but also know that API attacks go beyond just what's defined in the OWASP top 10. Incident response is also critical, right? How do you integrate or interface with your security operations teams? Are you feeding the right signals into their SIM solutions or SOAR? To provide the right signals that you can flow through your incident response playbooks and notify the right parties when there is an API attack going on. And then we talked about eliminating those vulnerabilities, right? Ultimately, that is a workflow issue, right? So we have to be able to integrate into service tools like the Atlassian suite or ServiceNow, depending what the organization is working within. But we want to make sure we integrate with existing employee workflows, not introduce something new that's disruptive to creation and maintenance of APIs. With that, Nicolas, I will hand it over to you. I think we're actually right on time, which is awesome.
That's perfect. Thanks a lot, Michael. So let me share my screen. That seems to be okay. Do you see well my screen?
Yep, looks good, Nicolas. Thank you.
Super, Michael, thanks. So I will do a demonstration of the product. That's what you are waiting for. We have been working hard, so you can just plug in with your SIM, with your SOAR, with your existing infrastructure. So you can use the product and get all the benefit without even connecting to the UI. But let me do a quick tour. So this is the overview, and where you connect in the morning and quickly see if there is anything that requires your attention. And it starts with attacker, and we'll be see in the second part of the demo. But what you have here is attacks that require your attention. And we don't just see attempts, we see correlated attempts, and we see what are the attackers that are malicious and of high severity. You will also get the visibility into what are the attacker, and we'll be able to quickly just mouse over and see what are the attacks that we are seeing for each of these attackers. But before that, it all starts with a blank screen, because the solution just starts from zero knowledge, and you will just, by looking at your API traffic, by just getting it from your load balancer, your API gateways, or your existing infrastructure, what are the APIs that we are seeing and discovering for you? What are the endpoints, meaning the function of your APIs? And that's usually where the surprise starts when we are testing the solution and doing vulnerability assessment or proof of value in a prospect environment. And what we tend to see is that 30 to 80% of the endpoint that we are discovering are not correctly documented or not documented at all. So without more waiting, just let's drill down into this discovery part. And the first thing that we show you is what are the new APIs and what are the new endpoints. As Michael was stating, what we see is that a lot of companies have the maturity of the initial onboarding. And there is a process, and all that goes well for the first version. But we are seeing some environment where API is in the version 48, and between the version 1 and version 48, there is just nothing in common anymore. And that's where the API drift starts. So we are showing you the endpoints inside the APIs who have drastically changed. Below, you will have the list of all APIs. And for each of them, are they processing any sensitive data? What's the name of the API? What is the server hosting it? How many endpoints does it have? And then there is tags. And our customers are using tags for many different things. First, on which environment were this API being discovered? Was it in AWS? Was it on-premise? Is it associated to a production environment, to a QA environment? You can just use tags automatically at time of API traffic acquisition, or manually also. And you can define at API level and inherit at all the sub-level of the endpoint and the payload. So let's just filter down on production. And what we are seeing here is that we have 4 APIs that are in production. Let's go into the next level. And in payment API, we are seeing all the endpoints with the method that is associated to it, with a different color code for get, post, and all the distinct methods that allow to call endpoints. And on the right part, you see that inside the name, instead of showing you thousands of distinct endpoints, we are correlating and automatically discovering what is the variable inside the URL. And on this first example, we see that we can discover at the end of the URL, and that's the simplest use case, but we can also detect it in the middle. And I've seen recently during a proof of value that we are also able to detect multiple variables inside a unique URL. And the next step is that you can even go to the payload level. And inside this post v1 charge, what we are able to see is what's on the request, what's on the response, and we support JSON, but also XML, SOAP, GraphQL that we have introduced just a few weeks ago. And then we can see all the parameters, may it be in the URL, in the header, or in the contents. And for each of these parameters, what we are doing is that we are automatically detecting what is the parameter type. And if it's an object like this fraud detail, what we are able to do is automatically do a flattening. So you can see what are the sub-objects, and we are detecting dynamically what's the parameter type. And for this fraud detail account, we are detecting that it's an IBAN and it's an account number, and we automatically set it as sensitive parameter. And we do the same for any PII. So here there's a mail address or a shipping address or name or phone number. All that is automatically detected to be sensitive. And if there is any type that you consider sensitive in your business that is not automatically detected, you can just click on it. The solution will search for all similar parameters in all other API and API endpoints. you can just mark as sensitive and in single click apply it to all of them. So they are all marked as sensitive. We do the same thing for the response, but in the response, there is a bit of context. If the response is 200, meaning that the API just processed it, while everything was okay, there is the value of what are the response and the parameter in the response for that. But we are also able to detect what is the normal response when there is an error and make sure that if there is an error, it's behaving the way that you expect. Let's go back to the API level. In this payment API level, what you can do is download the Open API specification that we have dynamically built based on your traffic. It means that a developer, I used to be one a very long time ago, and clearly the fun part of my day was not writing specification or documentation. And talking with developer again, I see that sometimes it's not the case also. So what you can do here is just download the specification and send to them so they can import in Insomnia, Postman, or their developer tools and immediately compare it to detect if their specifications are the same as the one that we have detected by looking at the traffic. But we can also work the other way around, meaning that DevOps team can send you all the specification for one API, so you can import one or multiple files, and then we can, in a single click, decide to compare it against an API that have been discovered and immediately get a report like this one. So on the first widget, what we have is that Salt has discovered by listening to the API traffic 21 APIs. And out of the specification that have been uploaded, there is 16 that are documented. It means that 5 are not, and there is 5 shadow APIs. And what we see is that very often it's not API that are not documented, but it's API that have been deprecated, but not removed from production. And that's usually where the biggest flaws are found, because they still have access to the data, but they are not tested, and that's a target of choice for an attacker. On the second widget, we have the same information, but filter on the endpoints that are processing sensitive data. And the last one is from the parameter point of view. And let me give you some more context about the parameter. If we get back to the same endpoint that we have just seen, the V1 charge, what we have here is the shipping address, and it tells that there is nothing in the OS type, and we have discovered it as a string, so it's a non-documented parameter and a sensitive parameter. Regarding the metadata order ID, that's something that is documented to be a string, and what we see by discovering at what's happening on the wire, there is an integer. So it's a discrepancy. It's not something that is correctly described in the specification. And since we have been able to learn all your APIs, all your API endpoints, all the parameters, the next step is about compliance. And if you have to do a compliance audit, you may want to do it for PCI DSS, for GDPR, for any type of data. We have already done the classification for all these endpoints, all these parameters. So if you want to just look at credit card and names for a PCI DSS compliance test, you can just click on it, and it will give you all the API, all the endpoints, and the parameter names that are associated to credit card or name. And you can do that now, but you can also get back in the last 12 months to get context. And if you have, for example, introduced some data that you don't expect to see in the response, to understand when was the change that introduced this data in the response for the first time. And if you look at, for example, the Facebook event where a developer just did a mistake and start putting some authentication key in the response. They didn't find it for months, and they got 50 million accounts that have been compromised due to that. So in such a use case, you can just check what are in the response data that are of a token type, and filter down and see any API that would have something that is abnormal, like a token in response. Then what we have, and that will be the last part of our discovery, is the security insight. That's the dashboard that you want from a security officer point of view. It will give you information such as sensitive data in the URL. And I remember one of our prospects in fintech that I've just starting discovering all the API that they had. And then they have started to see some authorization token and some sensitive data that was flowing through the URL. And this is something that is very serious regarding security, because if you have an insider attacker and you just look at the proxy log, you have all the information and it doesn't require login and password anymore, just using the authorization token, you will be able to authenticate as a third-party user. If you have a virus on a device, it will be able to access this information that resides in the browser cache. So that's something very serious. We are also seeing how digitalization is pushing hard on the DevOps team. And just in the past 3 months, I've seen some new API that have been pushed to production. And looking at the traffic, we have been able to see that this API didn't require authentication in order to return some data. And here what we have is the sensitive data that have been returned and sent in the response without even authentication. And finally, there is the highly sensitive data in the response. For example, while it's totally okay to put your credit card number when you are willing to pay on an e-commerce website, you never ever want to get this information returned when you are going to your user account portal. Because if your credentials are compromised, it means that somebody would be able to get your credit card information. And if there is a permission flow that allows to see another user account, and we will cover that in the attack in a minute, but it's something that we see a lot in the vulnerability assessment that we are doing. It means that the full database of all customers and credit card information would be leaked. And I've been discussing with some very large organizations in France, and they have been deploying some mobile application. And while the UI is totally clear, but when looking at the API and what are the response, I've seen on my user account that my IBAN information was sent in full clear text without any masking. And that's something that we are automatically able to discover. Now, let's go to the attacker part. I will keep some time for questions, so feel free to send in the chat before the end of the demo. In this action required, what we have is high severity and malicious attempts. And what we have is not just attempts, it's attempts correlated, and we can use any correlator in your API traffic, maybe a device ID, a user ID, an IP, even if we see that good attackers are not using the same IP to do a full attack, authorization token. We can correlate on any of this automatically to detect what is an attacker, because we know that attacker, when they are blocked, when doing an attack, they continue to do another one until they are successful. So blocking just a single attack is useless. What you want to do is to have the full understanding and block the attacker. So what we have here is a user ID that have done 18 attempts. And if we look at the summary, we are seeing all the endpoints that have been attacked by this attacker. What were the service response? What are the attack type? We support the full OWASP API top 10 and more than that. And we see that this attacker has quite a wide coverage of all the potential attack. Today, I will just focus on one attack. It's not SALT, it's OWASP that tells that the most severe is OWASP API 1, then 2, then 3. And OWASP API 1 is 40% of the attack that SALT is blocking for our customer today. And the reason why is that it's not just the most common attack, it's that it's the attack that is not blocked by legacy security solution. So it's the one that's come to solve and that we are seeing. Coming to source, you will have the details of information that explain why we have correlated all these attempts to one attacker. And what we are seeing here is that this attacker has been using one IP to do an attempt, then changing to another one and another one. And that is very common to have an attacker that is changing IP a lot because it's just effortless to change IP. But it's way harder to change and get a new user on APIs that are not open and not fully public. Then going to the timeline, what we are seeing is all these attempts, you can then filter based on the server response, the endpoints, and the attack type. So let's filter on the OWASP API one, the potential broken object level authorization. So we are detecting two. I will focus just on second one. That tells us we have an attack, and we know that because the authorization user ID in the header and the cookie user ID in the header are not identical as expected. Let me go into more details. On the left part, you have the request. On the right part, we have the response. The first part that we see is the authorization. So it's just an encoded JSON Web Token, and we automatically decode it for you. And it allows you to see what's inside the JSON Web Token, the authorization algorithm, user ID. And what we see is that the user ID is just 277. Basically, the attacker is just using his authorization from his normal user because he knows that it will allow it to pass the legacy security solution, the one that are taking care of the authentication. And then this attacker is manipulating the cookie and is changing the user ID in the cookie. We see that it's not 277, it's ending with 053. And what we see in the response is that the response is 200 OK, meaning that the API has just processed the request and not blocked the fact that there was some inconsistent data in the request. And then it returned the account balance, and we see that the user ID for which it has is 053. It means that if the attacker then do the same for 54 and 55, he will be able to dump and get access to all user database. So how Salt is detecting such an attack? We are able to detect this because we have looked at the traffic of a user from an hour ago, a day ago, or a week ago, and for that you need big data. And we have automatically detected that there is a correlation in this encoded field and the cookie, and these values are always the same on the baseline, on the legitimate traffic. And as soon as we detect that this correlation is lost, we are able to raise the fact that it's an OWASP API 1 attack. And then what we are able to do is to take action, maybe manually or automatically, and we can block the IP, or we can block the user ID with the solutions that are already in place. And finally, what you see here is that you also have the remediation. Remediation is what allows you to shift left and to send back to the DevOps team how to remediate and make sure that this flow is removed from the API. And what we tell here is that in the payment API, in this endpoint, the code should validate that the cookie user ID is the same as the authorization user ID. And if not, it should return a 400 response code. And the attempt timeline is also sent to the DevOps, so they are all the context to understand why they should do this change and what is the severity associated to it. We have few time today, so let me cut the demo for now. If you want to have a more complete demo, we'll be happy to organize that, and let me open to question.
Thanks, Nicolas. That was awesome. I'm going to wrap it up real quick, and then we'll get to the questions. As Nicolas said, there's a lot to cover. There's a lot in the platform. There's a lot, but there's also a lot to how attackers abuse APIs. You saw kind of the timeline, which I think is awesome, right? That's kind of how SecOps team would kind of view the problem. But remediations, right? How should servers respond? And then you also see how attackers switch between IP addresses, right? And it's actually really easy for them to do that, right? Because they will also use cloud compute and ephemeral compute, just like we are, right? When we're building APIs and systems, right? Cloud elasticity. And that's kind of why rate limits and IP address allow and deny lists just don't scale for this problem. So there's been a lot here, and we could probably spend hours more kind of talking through these problems. But we did want to leave you with some recommendations, right? It's not all bad news. If you are documenting your APIs, please do continue to do that, right? There is value in it, but just acknowledge that, you can't document everything in an API specification, right? It's not necessary. It's also time consuming, right? It is a semi-manual process, even though tooling is a lot more plentiful these days to generate those specifications. Nicolas mentioned Postman, right, which is very common tooling, right? So you can kind of mock and generate some of that schema as you're coding. But again, we still see gaps there. It just it doesn't materialize, right? It's hard to kind of scale that when you think about all the development going on and all of the system integrations, including third-party integrations, working with your partners or suppliers. Use your API gateways, right? Don't throw them out. They are very important as mediation mechanisms and those access control enforcement points and traffic management, right? I mentioned attackers will fluctuate between IP addresses, and Nicolas kind of showed you that in the demo, right? We see that often in attacks. So those IP address allow and deny lists and rate limits can work, right? But they also need to scale, right? And they kind of need machine assistance to inform those traffic management mechanisms. They don't really work by themselves. Prepare for business logic attacks by seeking more than the API threat protection filters. We talked about them. Your API gateway vendor might just call them message filters. They are essentially just looking at, API requests, sometimes responses. It depends on the vendor if it is looking in both directions, but then looking for no malicious character sets to block things. The OWASP API security top 10 injection attacks is actually only one particular finding there. So there's a lot more you need to be careful with. If you are looking for API security tooling, and I would certainly encourage you to, if you are building and integrating APIs, you really need a platform that can offer you this machine assistance and full context. It has to have flexible deployment options, right? Because your architecture is likely not greenfield, right? You're probably working with new technology and old. So monoliths and microservices, right? And your workflows can be all over the place as well. So any solution needs to work with all of it. It's kind of a tall order. There's a lot of material that we've worked very diligently to produce for industry. Many of them are listed here. If you don't know what the OWASP API Security Top 10 is, that's fine. It is newer, right? It was just published in 2019. We still encounter many organizations that don't even know what each top 10 item is. So please, by all means, take a look at the content. If you have any feedback, certainly let me know. That's kind of how I fill my days here at SALT. And our contact info is listed there at the bottom. So please do reach out or connect on LinkedIn. And we have about 5 minutes, it looks like, for Q&A. So did we get any questions?
Yeah, there is a question from Denise. I see the first question, which is how do you recognize documented, not documented API endpoint? So we are learning everything from traffic. So we can start from zero knowledge. We don't need any documentation, but the comparison that you have seen on the second dashboard require to have an open API specification, and we import one or multiple one, and then we are able to do comparison against what we have discovered automatically. So there is another question regarding custom pattern for sensitive data detection. Absolutely. I got the use case a few weeks ago where I've been requested to have some Brazilian social security number being detected. And yes, we have added support for such sensitive data automatic detection. And may you have any data with a standardized format, we can add support for this. A lot of questions, so let me...
Unfortunately, they get buried in the chat. If we don't get anything to all the questions today, too, you can certainly send them to us through email.
Yeah. So yes, it's possible to act automatically. So I've shown today how you can do it manually. But what we see is that our customers are doing it manually, usually for a few weeks, and then enforce it to be automated. So the integration that we had, the single click to block an IP or a user ID or the malicious traffic can also be automated. Thanks a lot for your question and attending. Amongst the resource that that Michael has written and recommended, I highly recommend API Security for Dummies. It's a very good introduction within a few minutes, and if you really go into all the details, maybe 2 hours, you get the very first level of API security, and it's been very useful for me when I've joined Salt. And we'll be also happy to have some education sessions that are dedicated and to go through the OWASP API Top 10 and the Mitre mapping for APIs attack and more than that.
Yeah, absolutely, Nicolas. Yeah, and the it's interesting. Nicolas was talking about BOLA, or broken object level authorization attacks. We do see them very frequently. If you notice at the bottom of the list, there's 2 reports. There's more to come. But BOLA is present in almost every customer we run into, and you actually see technical examples of BOLA attacks in both of those threat reports. All right, looks like we're good on time, Nicolas. Thank you again for that tech demo. That was awesome. Thanks everybody for attending. Again, if we didn't get to your question, or if you just want more info, please reach out to myself or Nicolas, and we'll be happy to assist. But thank you. Enjoy the rest of the conference, and we'll hopefully be talking to you soon.